Yeah, I want to welcome you to another interesting moment in our instructional video or in our online facilitation classes. Today, we'll be looking at soil mapping and classification. Looking at soil mapping and classification. And by introduction, said a map or a map unit is a collection of areas defined as well as named, same in terms of their soil component. So each map unit defined in some respect from all other in a survey area and unique, is uniquely identified on a soil map. So each individual area on the map becomes a delineation. So soil survey or soil mapping is the process of classifying soils or soil types and other soil properties in a given area, as well as geocoding such information. So it applies the principles of soil science. It draws from geomorphology. It also draws from theories of soil formation. It draws from physical geography, analysis of vegetation, as well as land use patterns. So the primary data for soil survey are acquired by field sampling, supported by remote sensing, principally area photography. So soil mapping. Now, the term soil survey may also be used as a noun to describe published results. The information is used by farmers and ranchers to help determine whether a particular soil type is suited for crop or livestock, and what type of management might be required. So an architect or engineer might use the engineering properties of a soil to determine whether or not this soil is suitable for a certain type of construction. Soil survey component. Typical information in a published soil survey include the following: a brief overview of the area's geography, a brief overview of the area's geography. You need to have an information about the geography of the area to be surveyed. You need to summarize the geography of the area. That talks about the mountains, the hills, the streams, if there are, the valleys, the vegetation in those areas, and all of that. These are some of the information that you need to summarize, you need to give an overview of these very vital information. So a general soil map with a brief description of each of the major soil types found in the area. So there is need to have a brief description of each of the major soil types that are found in the area, along with their characteristics, as well as the detailed area photographs with specific soil types outlined as well as indexed. Also, the photograph of some of the typical soils found in the area are also very, very important. The photograph of some of the typical soils found in the area that is being mapped. Now, tables that contain general information about the various soils, such as the total area, total area is very important. The comparison of production of typical crops, as well as common range plants. They also include extensive interpretations for land use planning, such as limitations for dwellings, with and without basement, shallow excavations, small commercial buildings, septic tank absorptions, suitability for development, construction, as well as water management. All of this information are very, very important. The area, the dwelling, the water network in this area, the excavations, commercial buildings, the septic tanks absorptions, as well as the suitability of areas being studied for development, as well as constructions and that just facilitated. So now soil classification deals with the systematic categorization of soils based on distinguished characteristics, as well as criteria that states choices in each in use, choices in use. Now, application in the field is a challenge due to the complex nature of soil formation, inherent capacity of the soil resource. So, classification of soil is obvious to farmers and researchers to enable active utilization by the farmer, scientific communication, easy study for research, among other things. So this unit will provide you with simple soil classification plans too. So soil classification is a dynamic subject, from the structure of the system itself to the definition of classes, and finally in the application in the field. So it can be approached from both the perspective of pedogenesis as well as from soil morphology. So different concepts of pedogenesis and differences in the significance of morphological features, various land uses, can affect the classification approach. So despite these differences in a well-constructed system, classification criteria groups similar concepts so that interpretations do not vary widely. And interpretations do not vary widely. Now, the first unit of soil classification is the order. Of course, you know that in the USDA soil taxonomy, we used to have 10 soil orders, but recently it has been upgraded to 12 soil orders. And these orders, when we mention the orders, we have the sub-orders. We have the sub-orders, we have the grade groups, we have the subgroups, and then we have the families and series. So soil orders may include something like arphosaurs, altisaurs, vertisaurs, insectisaurs, spodosaurs, apidisaurs, altisaurs, and so on and so forth. About 12 of them. And the like, as I said, that orders, they are the highest category of soil classification. And the other types end in the letters SO. So in the USDA classification system, there are 12 soil orders. And when we talk about empty soils now, we're talking about recently formed soils that lack well-developed horizons. We talk about empty soils. We're talking about recently formed soils that lack well-developed horizons, commonly found on unconsolidated sediments like sand, and some have A horizons on top of the bedrock. Now we also have vertisols, and vertisols are inverted soils, and they tend to swell when they are wet, shrink when they're dry. So often forming deep cracks that surface on the surface layers during the dry season. They had very wide cracks when there is dryness, and when these soils absorb moisture, they will swell and all of that. So insect soils also are young soils. Soils are young soils. They have subsurface horizon formation, but they show little elevation and illumination. When we talk about elevation, we're talking about movement of materials out. Elevation is where these materials that moved out of a particular horizon, where they are entering. So they are the alluvial and alluvial layers. So now, aridi soils are dry soils forming under desert conditions. So they include nearly 20% of soils of the earth, and soil formation is very slow. And there is also accumulated organic matter. These soils are very scarce. So they may have a subsurface zones, or otherwise called the calcic horizon, where calcium carbonate have accumulated from percolating water. Calcium carbonate have accumulated from percolating water. So many aridi soils or soils have where developed the horizon, showing clay movement from past period or more moisture. We have molly soils, and of course, molly soils are soft soils. Then we have the spodosols. It's called the spodosols are soils that are produced by ozolization. They are typical soils of coniferous and deciduous forests in the climate. So arphisols, or soils with aluminium and iron, they have horizons of where clay accumulates and form, where there is enough moisture and warmth for at least 3 months of plant growth. In addition to that, we have orthosols. Of course, orthosols are soils that are heavily leached. Most of the soils, especially in the southeastern Nigeria, can be best classified as orthosols. These are soils that have experienced extreme stage of weathering, and that is to say, soil that have experienced extreme weather conditions, two extremes of weather conditions. When during rainfall, they experience rainfall to the extreme. There is excessive rainfall in those areas, and during the sunlight or during the hot weather, we also have extreme weather condition affecting them. So these have made these soils to have come to a very extreme weather experience that they have had. So we now say that these soils are orthosols. They are also highly leached because of the extreme rainfalls in this soil. There is leaching taking place, which has to do with removal of organic matter, removal of nutrient, removal of oxides of iron and aluminium oxide, leaching of some very important materials in these soils are being washed out and being washed down. So all these soils soils with heavy oxide. They have heavy oxide content. Also, we have the histosols. Histosols also soils. Histosols are organic matter accumulation. Antisols are volcanic soils. tends to be high in glass. They are very high in glass contents that have permafrost. So it's high permafrost content. Now, by conclusion, we now say that there is a need for accurate, up to date, as well as spatially referenced soil information. These needs have been expressed by the modeling community, land users, and this need coincides with enormous leap in the technology and predicting soil properties, accurately predicting as well as collecting soil properties. So soil classification means that one finds categories of soil that are based on general characteristics as well as criteria that decides about the use that use is possible. So thank you for listening to this class on soil mapping, soil mapping and classification. So hopefully in the subsequent week, I'll go to the instructional video sections in the course page, listen to the instructional videos. Please remember to go watch videos as well as always do your best to follow in the classes. So thank you as you participate effectively in this class. Be blessed. Bye. See you.